In order to study the end behavior of polynomials, we want to remember these four graphs. So notice f of x equals x square is a parabola that opens up, and if you have f of x equals negative x square, that's going to open down. So these two, they have even degree. Notice the degree exponent is 2. And then notice these two graphs. F of x equals x cube starts low on the left and then goes high on the right. And f of x equals negative x cube starts high on the left and then goes low on the right. Now, let me remind you what a polynomial is. So let me write down a few examples of polynomials. So something like 3x to the 4 minus 7x cubed plus 25x square plus 3x plus 2. That is a polynomial whose degree is 4, the highest power. Now let me write down some more. Say this time I'm going to have negative 5x to the 6 plus 3x square plus 2x minus 11. Let's write down one more. Say this time let's take 7x cubed plus 2x minus 10. And also let's do one more. Negative 8x to the 5 plus 4x square plus 3x minus 8. How about that? Notice, when you talk about polynomials, there are two important characteristics of a polynomial. These are the two things we care about. One is the degree. Degree is that exponent, the highest power of x. The degree cannot be negative. It's a whole number. It could be either something like 4 or 6 or 3. So these are all counting numbers. Or if you have a constant polynomial, degree could be even 0, but never negative. And degree is always a whole number, so it could be either odd or even. So degree is one important characteristic of a polynomial. Now the other important characteristic is the leading coefficient. So what's the leading coefficient? Leading coefficient is the number that appears in front of the leading term. So the highest power is the degree of the polynomial is given by the highest power, and then the term containing the highest power is called the leading term. Now leading term here is, or leading coefficient is 3. Here it's negative 5, here it's positive 7, here it's negative 8. Now leading coefficient can never be 0, but it could be. Now whether it's even or odd is immaterial. What we care is this, is it positive or is it negative? So leading coefficient could be either positive or negative. So degree could be odd or even. Leading coefficient could be positive or negative. These two characteristics, degree and leading coefficient, will classify all polynomials into 4 categories. So you could have, so category A, or you could have odd degree and positive, let me write down positive leading coefficient, positive LC. Or you could have odd degree negative leading coefficient, or you could have even positive, so even degree and positive leading coefficient, or even degree and negative leading coefficient. So there are these four categories based on degree and the sign of the leading coefficient. And this is what we want to remember. So if the degree is even, so this is even and positive. So let's write it here. Maybe I will use a different color. So I'll just say even degree and positive leading coefficient. So positive LC. This is even and negative LC because the exponent is 2, which means the degree is even. Notice this is odd degree and positive leading coefficient, and this is odd and negative leading coefficient. And these four examples will tell us what happens when we go towards the left or towards the right. End behavior means we want to make x either large positive or large negative. Similarly, we want to study what happens when x goes to either positive infinity or negative infinity. So thinking about these four graphs, let's write down the characteristics. So case A, let's take even degree and positive leading coefficient. So this is an example would be f of x equals x square. So what do you notice? As x approaches positive infinity, y also approaches positive infinity. And as x approaches negative infinity, y approaches positive infinity again. So let's look at this graph again. When you move far to the right, the graph is going higher. When you move far to the left, the graph is again going higher. So when you have even degree, it either opens up or goes to positive infinity on both sides, or it goes to negative infinity on both sides. And that's what we are writing here for even degree positive leading coefficient. Now let's talk about even degree and negative leading coefficient. And this example is f of x equals negative x square. And what do you notice in the graph? Whenever x approaches infinity or negative infinity, we saw that y, so if x approaches positive infinity or negative infinity, y is approaching negative infinity. It's opening down. So y approaches negative infinity. In C, I'm going to have odd degree and positive leading coefficient. So maybe I should separate them, put them in boxes. So let's do that. So odd degree positive leading coefficient, and that example is x cube, positive leading coefficient. So what do you notice here? As x approaches infinity, notice for x cube, when x approaches positive infinity, y also approaches positive infinity. And when x approaches negative infinity, y is approaching negative infinity. So as x approaches positive infinity, y approaches positive infinity. And as x approaches negative, y approaches negative infinity as well. So again, and then finally odd degree negative leading coefficient. And that example is negative x cube. And what do we notice? The behavior is going to be opposite. So as x approaches positive infinity, y approaches negative infinity here. And as x approaches negative infinity, y approaches positive infinity. So you can see that for negative x cube, as x approaches positive infinity, y is going down. Whereas as x approaches negative infinity, y is going up. And these are the four end behaviors of polynomials provided by those four graphs: x square, negative x square, x cube, negative x cube.